Show that the line given by the equation Lx plus my plus n equals to 0 touches the circle x minus a whole squared plus y minus b whole squared equals to r squared whenever this particular criterion is met. Let us begin. Now, in order to solve this problem, we'll have to use the condition of tangency. We will begin by considering a circle. Now, since the equation of the circle is given in its standard form, here the value a and b that will represent the coordinates of the center. So, our coordinates of the center are a comma b, and the radius of the circle is going to be r. Now, let's say we have a line which is tangent to the circle at the point A. And the equation of the tangent line is given to us. That's Lx plus my plus n equals to 0. Now, first what we'll do, let's find out the distance of the point C from the straight line whose equation is given to us. So, we'll come back to the tangency problem in a moment. So, here the distance of point C from the straight line will be CA equals to, we'll have to take the absolute value. Now, inside the absolute value, we'll have to take a ratio. In the numerator, we'll start by considering the x-coordinate of the center. So, that's A. This will get multiplied to the coefficient of the line. This is not m, this is x. We'll have to consider the coefficient of x, which is L. Added to the y-coordinate of the center. So, that's B. B will get multiplied to the coefficient of y of the straight line. So, that's m. And then we add to it the constant term, which is n, divided by the square root of, we'll need the coefficient of x, which is L, which this will be squared, and added to the square of the coefficient of y. So that's m. That will be m squared. So this is the distance of the point C from the straight line. Now, luckily for us, this straight line is also the radius of the circle. So CA is also the radius of the circle. So that means R must be equals to the absolute value of AL plus BM plus N whole divided by square root of L squared plus M squared. Now we'll do one thing. We're going to square both sides to get rid of the absolute value. So R squared will be equals to AL plus BM plus N whole squared divided by L squared plus M squared. And we are almost done. So if we cross multiply, we are going to get AL plus BM plus N whole squared. This will be equals to the radius squared multiplied to L squared plus M squared. So this condition was given to us. So we are getting the final condition. That means if the straight line is tangent to the circle at point A, then definitely we will get the condition that AL plus BM plus N whole squared equals R squared times L squared plus M squared.